one of the deliverables for the SYSC 4907 fourth year project. The scope of the project is the implementation of the reconstruction of undersampled signals using compressive sensing on an FPGA. The compression of a signal involves reducing the size of the signal from its original raw data. Using compression techniques can be especially useful when transmitting signals that contain sparse data, as this data contains lots of zero values which are not meaningless but still zero. Compressive sensing uses linear dimensionality reduction to acquire condensed representations of sparse signals. In this process, signals are brought from a high-dimensional space to a low-dimensional space using linear algebra properties. They are then transmitted and finally approximated using reconstruction algorithms with very minimal data loss.
When implementing our reconstruction algorithm, we decided to use the OMP algorithm. This was due to its relative simplicity and speed when compared to other matching pursuit algorithms, convex relaxation algorithms, and Bayesian techniques. We implemented our design in Vivado HLS design suite using the C programming language. This was chosen as Vivado HLS provides much quicker implementation and shorter synthesize times as opposed to hardware description language for programming the FPGA. This resulted in a trade-off of performance, as HLS resulted in slightly lower performance than HDL when implementing complex algorithms such as the OMP algorithm. Vivado HLS actually does is transforms our C code into an RTL design. This was done by transforming our C code to work amongst the Vivado HLS C code standards, and as you can see in the bottom console output, when it is run through C simulation, it results in a mean squared error of 0. This was also tested with a variety of inputs through an automated testing server using Jenkins. Now, when our C code was working, it was time to work on the hardware implementation by synthesizing our code. After synthesis of our code, you can see that it resulted in a variety of performance metrics, as well as showcasing an interface that could be used as the OMP intellectual property block to be further used in hardware development.
Having our OMP algorithm in RTL allows us to integrate an intellectual property block that will be later programmed onto the FPGA along with our communication protocol. Our end-to-end solution includes a heart rate sensor, which is sampled via GPIO pins on a Raspberry Pi. Once our signal is sampled at Nyquist rate, we use a script to compress the data using linear dimensionality reduction. Our signal is then compressed to 64 elements down from 256 and is ready to be transmitted from Raspberry Pi to FPGA. Our solution then implements a serial peripheral interface, also known as the SPI protocol, on both systems to communicate all 64 elements synchronously. Once the compressed signal is received on the FPGA, our hardware is designed to pass it as input to our OMP algorithm, which is instantiated as an IP block or a submodule. Our hardware design will then return an approximation of the original sampled signal and communicate all 256 elements back to the Raspberry Pi using a similar communication design.
Our group also attempted to reduce power consumption using fixed point numbers. Thanks for listening.